Hello guys, this is going to be section 7 of my C++ tutorial. In this video we're going to get into set precision and fixed string manipulators, how to generate random numbers, as well as the POW function, okay? So, like all the others, we're going to go ahead and get into Visual Studio. And the first thing we're going to talk about is we're going to talk about how to do fixed set precision string manipulator, which you'd use this if, let's say, you were calculating a price or maybe an average, but you don't want to go out past 2 decimal places. So you'd use a string manipulator, a stream manipulator, excuse me, to modify it to where it only shows 2 decimals, 2 digits following the decimal. Okay, so first off, I'm going to explain the fixed string manipulator, which is built into C++. You don't need anything extra. So we're just going to do float num. And then we're going to say cout, enter a number, and then prompt the user, and then I have them input it. And we're just going to say cout number, and then we're also, the next line is going to say cout number. But this one is going to have the fixed string manipulator prior to the num. And we want to end that line as well. Okay? So, and what this is going to do, it's going to allow you to print up to 6 decimal places. After that, you'd want to replace fixed with scientific, which would put it in scientific notation, okay? But we're just going to cover fixed, okay? So I'm going to run this and just show you what fixed does. So I'm just going to say 5. So you'll see if you just do a cout number and point to num, it's 5. But if you do cout number fixed num, it follows it with 6 zeros, okay? So now we're going to talk about the set precision manipulator, which to use set precision, you have to add a new directive. So do number include, and it's IO man IP, okay? And then what we're going to do now is we're going to do cout number, and then you still have to do fixed, but then add set precision parenthesis, and then how many digits you want to set that precision to. So I'm just going to say set precision to, as if we were talking about a price. Num and L. Okay. Now I'll run this and I'll actually use a decimal number, not just a 0.00. So I'll do 5.673. And as you'll see here, that the first one, since it was a float value, it displayed the entire number. The second one was displaying it out to 6 spaces after the decimal. And the third one, since we were using a set precision of 2, it only showed the first 2 following the decimal. Okay, that's going to be it for fixed and set precision. Okay, so the most important things in this are the include IO man IP directive, and then as well as the fixed and the set precision commands. Okay, and again, the set precision syntax is simply set precision parenthesis and the number you want to set it up to go after the decimal, okay? So I'm just gonna backspace all this. If you want, you can comment it off, okay? And then I'm also gonna remove this directive. Okay. So now we're gonna go on to the next one, which this actually deals with random numbers, okay? Random numbers, you can do a lot with them, but only if you know how to generate them correctly. So we're gonna do cout, and then just do rand, double parenthesis, and then end L, and copy this 3 times. So just Control C, and then just do Control V, Control V. And now hit Control F5. Okay, so 41, 18,467, and 6334. So now let's go ahead, and I'm going to run it again. And you'll notice that it's giving the exact same numbers, okay? And this is an issue because if it gives us the exact same numbers, then it's not really random. After one go through, you'll know what the numbers are going to be. So we're going to have to fix that. So what we're going to want to do, let me close these. You're going to have to go up here and add another directive. This is called number include and then C time. Okay? So now what we're going to want to do is, to fix this, we're going to say srand parenthesis static cast, and the data type is int, and then within the parenthesis following that you want to write time. Okay? And then do a 0 followed by 3 closing parentheses and then a semicolon. And now cout rand cout. And then basically do the same thing we did above, okay? And I'm just going to comment these top 3 off since we've already seen the flaw with using just the simple rand without this statement, okay? So let me go ahead and end this line as well. I gotta get a drink. Okay. So now that we added this, we're going to run it, and we'll take a look at these random numbers. So, this is the first run. We'll run it again. And this is the second run. So the numbers are different, okay? I mean, this one here is only a few away, whereas this one's 21,000 off, and this one is also 9,000 away. Okay, so what we're doing is it's not really random. It's hard to get a computer program to create something random. There's always a process and an algorithm to what it's doing. But when you're including C time, it's pulling information from the computer's clock, okay? So that's why you have to include this, and it kind of relies on this time to generate a very random number, okay? And you might be like, well, what are the boundaries for this? And it's usually between 0 and 32,000, I want to say 700 and some, okay? So those will be the numbers that you generate, okay? Between 0 and that, okay? But let's say we just want to roll a die, okay? So how we would do that, I'm going to comment this off as well, just since we've kind of covered what those commands do. So what we're going to want to say is we're going to create int random, and we're going to do the same command we used here. I'm actually just going to copy that just so I don't have to type it. So just paste that right there. And now what you're going to want to do is say random is equal to 1 plus rand parenthesis modulus parenthesis 6 minus 1 plus 1, okay? So what this is doing is, I'm going to comment this off. The method you want to do for this is lower bound plus rand, then modulus parenthesis the upper bound minus lower bound plus 1. Okay? So that is going to be the method you want to do, and this is inclusive, which means you will get the lower bound and you will also get the upper bound. So this could result in a number between 1 and 6. Okay? So that's important to make a note of. And I always forget a semicolon when I'm doing that. So I'll put a semicolon there. And now what I'm going to do is I'm going to do a for loop just to print these off, okay? So I don't have to copy that line over and over again. I'll say for int x equals 0. I'm going to try to get it to display all of them, at least one, so I'll just do x is less than 15. And then I'll say cout random number is just point to random. And that line. And then what you're going to want to do is you're going to want to copy this part of the code again so it generates a new random number every time it runs through the loop. Okay? So let's go ahead and run this. Okay, so you'll see that it did generate every number at least once, okay? Looks like a lot more 5s than anything else, and only 1 6, but it did generate one of each, well, at least one of each, okay? And actually, I'll leave that up and I'll just run it again, and we'll just look at the results and compare them. That way we can see that they are actually different. So it was a 5 both times, but after that it does change, okay? So that is how you're going to do random numbers, okay? Pretty easy once you get the hang of it. But in this one, this is what's important. Including ctime directive, then this kind of formula to get the random number set up. Remember, lower bound plus random, okay? Modulus, parenthesis, the upper bound minus the lower bound, and always do a +1 if you want to be inclusive, okay? So that's how we're going to do that. And the last thing we're going to talk about in this is the POW function, okay? So I'm going to go ahead and delete this. You can comment it off or maybe save it and start a new project. So the POW function, you're going to have to do number include, and this is going to be C math, okay? Now we're going to do float number equals 0, and I'll explain why we're using floats in a moment. Float power equals 0, and then float result. And we'll just do couts that prompt the user for both the number and the power. So enter number. And now what we're going to want to do, we're going to say result equals POW, parenthesis, number, comma, power, okay? And then we're going to do a cout. I'll explain the syntax to that command in a moment. Okay. So, this has been covered in previous videos, but for result equals POW, number, comma, power, so you say POW, which is the command to raise a number to a power, and the first number is the number you want to be, that you want to raise to a power, okay? So I'll just say number to be raised, and the second number is to what power, okay? So let's say we wanted to raise 3 to the second power, where in math it would just be 3 caret 2. You'd write that POW 3 comma 2. Okay? So that's kind of just an example. Here, I'll write EX. And that's how you would, I mean, of course, this is how you do a power in English, which of course that'd be 9. And this will take 3, and you need to do it twice. So 3 times 3 is, of course, 9. Okay? And once I add a semicolon here, I'll actually run through this and we'll use some different numbers. So I'll do 5, and we'll do it to the third power, which is 125, okay? And this is going to be pretty useful. Let's say you wanted to calculate maybe the circumference of a circle or the area. Or maybe you're trying to do the Pythagorean theorem and you need a square number. Now, the reason we stored these values as floats is because, like in the Pythagorean theorem, if you have just say a squared and b squared, but you and then once you get those two and add those together, you have to take the square root. So if we did an int and we input 0.5, which is how you do the square root, it would truncate that and take it down to just plain 0, okay? So that's why we held these as floats, okay? So I'll actually do one where we want to take the square root of a number. So run it. So let's say we want to take the square root. I'll just do 9. And we're going to just say 0.5. And that tells us that the result is 3, okay? Which that is, of course, the square root of 9, okay? So that is how to do powers. And there is going to be, you'll notice that if you put in a really high number, you'll get an error. Well, you'll get a very unusual output. This is called integer overflow, which I'm actually going to make a video just strictly about errors in programs. And I'll talk about that separately, okay? It'll just be a video focused on errors, how to avoid them, and possible solutions, okay? Like, if I was trying to raise 9 to just say the 70th power, well, of course, that just gives me the 1 point and then number INF. But there is a way to get it to just say a negative 2, like 2 billion. It'll give you a really ridiculous number. So let me try again. I'll try to get that. Yeah. So this is giving us 1.42109 times, well, E plus 0.32. But you can keep messing around with it, and at a certain point, it will, there's just a certain point when it quits giving you valid answers, okay? And that has to do with how the integers are being stored and saved, okay? And calculated. We'll try this. Okay, and even there, that's not an error, it's just outputting it set in a different way. Okay, so that's going to cover it for this video. My next video is going to get into how to do searches through arrays. And then probably the last video we'll talk about errors, which I already have a Prezi. So I'm only going to talk about one type of error in that video and then just put the link of the Prezi in the description, okay? So you can probably expect 2 more videos. And then the next language we're going to do is Python, okay? So, and you'll probably be able to expect that probably December, let me look, probably before Christmas, okay? So probably maybe the 23rd or 24th, I'll start getting probably about five Python videos up on here. And again, the Python will probably go to about 8 or 9, maybe 10 as well, okay? So that's going to be it for this video, guys. Thanks for watching. Hope to see you guys here next time.